Okay, so on the next one, y squared plus 4y plus 3, step 1 says to look for a GCF. There is no GCF between these three terms, so we go to step 2, which says how many terms do you have? Well, I have 1, 2, 3 terms here, so we know it's a trinomial. So I have to ask the question now, is a equal to 1? Well, if a is equal to 1, and it is, then we have an easy trinomial, yay, because there's a 1 in front of the y squared. So we have an easy trinomial, which says, I'm going to put a y and the y in both of the fronts of the binomial answer, and then I'm looking for two numbers that multiply to 3, but at the same time add to 4. So my factors of 3 are 1 times 3. Because 3 is positive, I know my signs are the same. In order to add to 4, they both have to be positive. Plus 1 plus 3. So we've done step 2, which determines the number of factors and then factor. Step 3 says, is the polynomial completely factored? Is there anything else I can factor in y plus 1? No. Is there anything else I can factor in y plus 3? No. So therefore, I have completely factored. The next problem, x cubed minus 125. Step 1 says, is there a GCF? Well, no, there's no GCF. Step 2 says, how many terms? Well, I've got 2 terms this time. So because I've got 2 terms, it has to be a binomial. Which binomial case is it? Well, because there's a little 3 up here, I know that's a cube, so we have a cubed, in this case minus, because there's a subtract, so it's going to be a difference of cubes. So I'm looking to make sure I know what is actually being cubed here. And the first one, clearly x is being cubed, because x times x times x is x cubed. And 125 is 5 cubed. So this is where I have a binomial and a trinomial. The binomial is pretty easy. All you have to do is take off the cubes and the x minus 5 just slips right in. On the trinomial is where we're going to look at it as 3 different products. The first one is x times itself, the last one is 5 times itself, and the one in the middle is like a little compromise, it's one of each. So we have x squared, 5x, and 25. Don't write 5 squared here. A lot of students sometimes will write 5 squared because they're trying to use the formula, and then you're just going to have to take another step to distribute out 5 squared. Just think of 5 times 5 is 25 and then put 25 right in there. Then I'm going to come back and use my SOAP. Same, opposite, always positive. The sign is negative, so the same is negative. Opposite is positive, always positive. And the last one. So this is my answer. Okay, on the next one, 16x squared minus 81. Step 1, is there a GCF? Nope, not in this one. Step 2, 2, 3, or 4 terms. Well, in this case, there's 2 terms, which means it's a binomial. Binomials always have formulas. So we have the a squared minus b squared formula, squared because the little exponent is a 2, and also 16 and 81 are perfect squares. So before I use the formula, I want to think about what is being squared on each of these terms. In order to get 16, I need to take 4 and square it. In this case, to get x squared is x squared, so 4x times 4x truly is 16x squared. To get 81, I need to write that as 9 squared. So a is when I'm using my formula, a is like the 4x and b is the 9. This is a difference of squares, which means I have one sign plus and one sign minus. The 4x goes in the front, the 9 goes in the back. Step 3 says, is there anything else that I can factor? Well, 4x plus 9 and 4x minus 9, there's nothing else that can be factored, and so I know that I am completely done. On the next problem, 14x squared minus 11xy plus 2y squared. Notice we have x's in the front and y's in the back, which is okay. Notice that the exponents go down from x squared to x to the invisible 1 there, and then no x's. So you had 2 x's, 1 x, and then no x. And then if you think about the y's, you have 2 y's in the back. You have only exponent of 1 y in the middle term. In the first term, you have none. So because my y's and x's go up and down nice and neatly, I know I can factor this the same way I factored the other trinomials. But step 1, starting with step 1 always, is there a GCF between 14, negative 11, and 2? No, I wish there was, but there's no GCF on this one. Step 2, how many terms? Well, there's 3 terms. Now, I know it's a trinomial, but is it an easy trinomial or a hard trinomial? I have to identify if a is equal to 1. A is 14, so therefore it's not 1. So because a is not 1, I need to use either guess and check or the AC method. Now, I prefer the guess and check, so that's what I'm going to show you here. So I have 14. The choices for 14 are 1 and 14, or 2 times 7. The choices for 2 are 1 times 2. So the choices for 2y squared are 1 times 2. Notice those have y's on them. So when I try these, I'm going to try the 2 and the 7 first because I usually try the lower ones on my list. So I'm going to try 2x and 7x. And the only choice I have in the back is 2 and 1. So don't write this down, but if you put the 2 and the 2 next to each other, if you put in this first parentheses, the 2 and the 2 next to each other would not make any sense because that would mean my answer has a GCF. We've already identified my whole problem doesn't have a GCF, so this wouldn't make much sense. If you went ahead and tried it, you're still going to get it wrong. 14 and 2 are not going to ever get you 11. So, but I'm telling you, don't even try that one. In fact, I wouldn't try it at all either. So I'm going to go ahead and erase all this. And instead of putting the 2 next to the 2, I'm going to put the 2 across from it. That way that nothing in the first parentheses or nothing in the second parentheses has a GCF. Now I'm going to go ahead and check that. And the way I check that is to cross multiply. So I have 7xy and 4xy. Now, because the 2 is positive, that means I either have a positive times a positive or a negative times a negative. In this case, I'm going to have 2 negatives. 7xy and 4xy do add to negative 11xy if they're both negative. So this factors into 2x minus 1y times 7x minus 2y. Is there anything else that can factor out of either of these two? No, so that's completely factored. Now, some students are always asking me, Miss, do you have to have the 1 in front of the y? No, you don't have to have the 1 in front of the y. You can also put it like this. And then the next student's going to say, hey, Miss, can I keep the 1 there? Yes, you may keep the 1 there if you really, really want, okay? All right, next problem. Step 1, is there a GCF? Nope, there's no GCF amongst any of these. Step 2, how many terms? 1, 2, 3 terms. Is a equal to 1? Yes, a is equal to 1, which means this is an easy trinomial. So because it's an easy trinomial, I have the x and x. I'm looking for 2 numbers that multiply to 25, yet at the same time add to 10. So my factors of 25 are 1 times 25 and 5 times 5. With both of the same signs, either positive times a positive or a negative times a negative, which one of these adds to 10? Well, looks like 5 and 5. Plus 5 will multiply to 25 but add to 10. Step 3, can either of these factor more? Nope. This is your final answer. Now, just like the last problem, I can rewrite it a different way. Whenever you have a binomial that's multiplied by itself, you can rewrite it as x plus 5 quantity squared. Again, both of the answers will be accepted as correct. You pick the one you like better. On our next problem, 9m squared plus 16n squared. We have step 1, is there a GCF? And the answer there is no. Step 2, how many terms do you have? 2, 3, or 4? In this case, we have 2 terms. And so that means it has to fit a formula. If it doesn't fit a formula, you can't factor it. In this case, it looks like we have squares because there's a little 2 in the exponent, and also because 9 and 16 are perfect squares. But we have an a squared plus a b squared. Well, we don't really have a formula for sum of squares. We only have a formula for difference of squares. We have a formula for sum of cubes, but there is no formula for sum of squares, and the reason there is no formula is because it doesn't factor. Because it doesn't factor, we know this is prime.